Equilibrium expressions involve concentration of products times each other over concentration of reactants times each other. The big question is, why can't solids and pure liquids be included in equilibrium expressions? Well, the quick answer is because the concentrations of solids and liquids are constant. Their concentrations don't change. And if their concentrations don't change, then solids and liquids wouldn't change equilibrium. So they're not included in equilibrium expressions. That's easy enough to remember. The bigger question is, how can it be that the concentrations of solids and pure liquids are constant? Concentration, also known as molarity, is a measure of moles per volume. It's used to measure solution concentration, like for aqueous solutions, as moles of solute per volume of solvent. And as the number of molecules or atoms of solute increases, volume of the solvent stays the same, so concentration of solution increases. So that leads to another big question. Why doesn't volume change as more solutes are added to solvent? Well, solutes dissolved in solvent are so tiny that their volume is considered negligible, meaning they do not occupy enough space to displace volume of solvent, nor is more solvent being added. Molarity can also measure gas concentration, whether gas molecules dissolved in solvent or gas in a sealed container. And as number of molecules or atoms of gas increases, volume of the rigid sealed container stays the same, so concentration of gas increases. So moles per volume fundamentally comes down to number of molecules or atoms in a fixed space. And when you think of it fundamentally like this and understand why concentration of solutions and gases can change, it's easy to understand why the concentration of solids and pure liquids does not change. But I'll show you exactly why. Take this solid metal cube, for example. It has a definite mass, definite shape, definite volume occupying a definite space, which means it's comprised of a definite number of molecules or atoms in the definite space it occupies. This means it does not easily lose molecules or atoms and will not easily take on any other molecules or atoms. The amount of molecules it has is the amount it will always have at constant non-melting temperature. So if the number of molecules can't change, the space it occupies doesn't change, and therefore concentration won't change. Now suppose we really wanted to increase the number of metal molecules, like for instance, double it. Well, the only way to do that with solids is to add a whole other solid with the same number of molecules or atoms to it, which would indeed double the number of molecules, but it also doubles the volume, which ultimately leaves it at the same concentration as it was before. This easily makes sense for insoluble solids like metals because they don't even dissolve in solvent. Rather, they precipitate, meaning just drop to the bottom, leaving the solvent above still pure. But then the question is, why aren't soluble solids included in equilibrium expressions, since they actually dissolve in solvent, creating a solution whose concentration can change? Well, because they're solid as reactants. Even soluble solids like salts and sugars are not included in equilibrium expressions because even though they may dissolve in solvent and can change solution concentration, before dissolving in solvent, they're solid reactants, and their concentration doesn't change, just like what we saw with metal solids. It's a similar thing when it comes to pure liquids, like with water in this example. It has a definite mass, taking the shape of its container, but with a definite volume, occupying a definite space, which means it's comprised of a definite number of molecules in the definite space it occupies. At constant non-evaporating temperature, the glass will not lose water molecules, meaning the amount of molecules it has is the amount it will always have at constant non-evaporating temperature. So if number of water molecules can't change, the space it occupies doesn't change, and therefore concentration won't change. Now, the only difference between solids and pure liquids is that you can add solute to liquid and increase the concentration of solution without changing the volume of liquid, like we saw before. However, the number of water molecules doesn't change, nor does the volume. Now, suppose we really wanted to increase the number of water molecules, like for instance, double it. Well, like we saw before with metals, the only way to do that with pure liquids is to add more water molecules, which would indeed double the number of molecules, but it also doubles the volume, which leaves it at the same concentration as it was before. So, solids and liquids are not included in equilibrium expressions because their concentrations are constant. And this is because as you add more moles of the solid or liquid, the volume increases proportionally, keeping the concentration of the solid or pure liquid ever constant. Simple as that.